Today we're going to do a review of integration. So let's title the notes Integration Review. This is stuff that we learned last semester, but in order to be successful in the next unit we're about to start, a good review of all these different kinds of methods is going to be very helpful. So we're going to go back over integration, how you do it, what we know how to do now, and what we're going to learn later on. So these are BC integration topics that we're about to do. This is AB stuff that we're doing today. AB covers two basic integration techniques. Number one is the power rule for integrals, and the other one is U-Substitution. That's all that AB kids have to learn. We're going to learn more. We're going to learn how to undo the product rule. Okay, we haven't talked about that at all. We've undone the chain rule. We haven't undone the product rule yet. And we're going to also learn about what are called improper integrals, where our limits of integration go from a number to infinity. How do you find an integral of that? That's coming up later on, okay? So let's review the rules that we know so far. So rules so far. So far is not one whole word, but we'll just let that go. So far, that bugs me. Anyway, the only rule that we really know how to use right now is the power rule. And this is in your flip chart. This is the one that is the integral of u to the n du. Whenever you have something to a power, the power can be positive, negative, a fraction. It could be pretty much anything. When you take the antiderivative, does the power go up or down? It goes up, so it would be n plus 1 for your u, and then what in front of it? 1 over n plus 1. And then what always goes on the end of these integrals? Plus c. Now, all of my examples are going to be indefinite integrals, which are integrals that you cannot do on the calculator anyway. The worksheet, however, will be half indefinite, half definite. Indefinite is where you just plug the numbers in. We just did that on How Sweet It Is the other day, so we've done that recently. Okay? So that is the rule that we're the most familiar with. Now, I'm going to go back to the flip chart and just show you. When we did the flip chart, the power rule was the first thing we wrote down. The only exception being n can't be 1. And when n is 1, do you remember what the rule is? ln. It's the ln rule. So all of the rest of these are, if it's not a power rule, what do you do? But it possibly can entail U-substitution. So having this by your side as you do your homework might be helpful, just to remember what the rules are to do the problems. And we may refer back to that in a little bit. Okay, so rule number 2 I want you to write is U-substitution. And there's no official rule for it like the power rule has, but it's just be on the lookout for U-substitution. Okay? And how do you know when you're going to do U-substitution?
If there's something inside of something.
If there's something inside of something, which indicates it came from a what kind of rule derivative?
Chain rule.
That's what I'm looking for, exactly. Watch for chain rule. Watch for chain rule as you do these problems, okay? So as we do the examples, some will be U-sub, some will not. And we're going to talk about the different methods to do them and how to know what to do in each one. So let's start with this example. The integral of x cubed plus 1 dx. Let me scoot that up. The integral of x cubed plus 1 dx. Does that problem require a U-sub?
No.
No. There's nothing inside of anything. The only thing inside of the power 3 is an x. So you don't need to do a U-sub for just an x. So all you do is just take the antiderivative using the power rule for every term. What is x to the third going to become? 1/4 x to the fourth plus x plus c. That's it. We're done. Easy enough, right? Okay. Next example. The integral of x squared times x cubed plus 1 to the 4th dx.
U-Sub.
Okay, some of you are already saying U-sub. What do you see that makes you think U-sub?
The parentheses and.
Parentheses to a power. That tends to be a cue that you need a U-sub. And in this case, we do. I'm going to use another color for my U-sub. You don't have to if you don't want to. But it really makes things stand out on the notes much better. So what is U in this instance? X cubed plus 1. Then you need to write du.
3x squared.
Now, du is 3x squared, but it is really 3x squared dx. And you need to get in that habit of writing that dx because on one of the lessons we're going to have coming up, the dx is very important. So make sure you write that down. Okay? Remember that when you do a du, that everything that has an x in it has to be in your integral. The only thing you can add in here or multiply in here is a constant. If you're missing x's, you're going the wrong way. Question?
I was going to ask about that, but you just explained.
Okay.
Because I did a U-substitution once, and the x was in the du, but there wasn't an x in the problem.
We're going to have a couple of those examples today, and I'll show you what to do when that comes up. Okay? So, to reiterate, if your du has x's, but your integral does not, your u is wrong. Or the fact that you're trying to do U-substitution is wrong. Okay? Question?
I was just going to ask, how is that possible? Like, how could an x end up in D?
Sometimes you're picking the wrong thing for you, and sometimes you have to go down a different path. I do have some examples we're going to do today where it looks like it's a U problem, but it's really not. And I'll show you what to do in those instances, okay? Any other questions? All right. Look at my du. What's it missing over here?
3.
I need the 3, so put the 3 in there. And what needs to go outside in the front?
1/3.
1/3. So I'm going to underline the stuff that creates du to separate it from everything else. So now I go to the next step and I write 1/3 integral.
U to the 4th du.
And the two things that I've underlined are the du, and the rest of it is u to the 4th. Now, is this starting to come back to you? It's been about Thanksgiving since we really did a lot of U-sub, so I know it's been a while. Okay? What is the next thing I'm supposed to do? Antiderivative, exactly. So this would be 1/3, draw your parentheses. U has a new power of what? 5. And so what goes in front? 1/5. Okay, remember that when your power goes up, your integral comes off. I don't write du and I don't write integral. But I do write what?
Bracket.
Not a bracket this time because I don't have a plus c. This one's a plus c. The bracket comes on when it's a definite integral. Okay? Am I done? No. What do I need to do? Change u back to x and clean up the numbers. So this will be 1/15 times u is x cubed plus 1 to the 5th plus c. And that's done. Okay? How could I check that answer? Take the derivative of it. If I take the derivative of this, I should end up with that without the extra numbers. I should end up with what I started with. Okay, so that's a good way to check yourself on a test. Your homework, of course, is going to have the answers on the back, but that's a way to check yourself on a test. Okay? Questions? All right, next problem. Example. This one's going to be a double line one. This is x dx over the square root of 1 minus x squared. Okay, what does your gut tell you? U-sub or no? U-sub. And you are probably right. I'm not going to say for sure whether or not you are, but we're going to try it. Sometimes you can mentally do a U-sub and see if it's going to work. If it is a U sub, what would U be?
1 minus x squared.
1 minus x squared, the inner function. So then what is du?
Negative 2x.
Negative 2x dx. Okay, do I have everything for my du except for the number?
Yeah.
Yes. If that is the case, you're on the right track. If you're missing x's, something's wrong. Okay? So this one needs a negative 2. And then what else does it need?
Negative 1/2.
Negative 1/2 goes in front. Okay, so now we're ready to change it to u's. So we're going to have negative 1/2 integral. Now, I'm going to circle my du so I don't accidentally put it in with something that it doesn't belong. And I personally like to write it out to the side. du, out to the side. So what do I have left? 1 over u to the 1/2. 1 over u to the 1/2. You could write 1 over the square root of u, but you would have to change it.
Is it alright if you wrote u to the negative 1?
Yes, let's talk. We're going to talk about that. Okay. Big question of the day. Is that an ln problem?
No.
No. Why not?
It's only 1 over u.
ln has to be 1 over plane u. It cannot be 1 over u to a power. Since it is not ln, how do I do it?
You move it to the top.
Move it up to the top and make it a negative exponent. So I'm still in this color. This is negative 1/2 integral u to the negative 1/2 du. Brownie points for Jason for getting that before we even got there. Good job. Okay. Now, is it time to switch back to x's?
We haven't taken
I haven't taken the antiderivative yet. I purposely kind of led you down a wrong path there. I purposely asked that question. I got to take the antiderivative first. So this will be negative 1/2 parentheses, not integral anymore. And then your u. What does u's power change to?
1/2.
Positive 1/2, because you're adding 1. So if that's a 1/2,
2.
2 goes in here. And what goes on the end? Plus c. Please don't forget to write plus c on both lines, the u line and the x line. So now we're ready to switch back to x's. So the negative 1/2 cancels the 2, so that's going to leave a negative 1. Now you can write u to the 1/2, or you can put it in a radical. I'm going to put it in a radical. 1 minus x squared plus c. And there we are. Whoosh. Scoot it down. Next example is going to look almost exactly like the one we just did. Integral dx over the square root of 1 minus x squared. Now some of you are on the same sheet of paper. I know you are. What's different between this one and the one we just did?
There's like,
It's missing the what? It's missing the x in the numerator. Okay? Now, if you were just looking at this problem first shot, you would think, oh, u sub. But if you did the u substitution from the previous problem, if you did the u sub from here, notice the du is negative 2x dx, but there's no x up there. So that's not going to work. Okay? So I can't do a u sub on this problem. It's not going to work that way. However, this is one of the integrals on your flip chart that we just wrote down. Pull your flip chart out and take a look. Which one is it? It is this one right here. It is sine inverse. So this is a direct, I don't need a u sub problem. It is only sine inverse of x plus c. Okay, so all I do, oops, let's put that over there, I may need it later, is I just write sine inverse of x plus c, and I'm done. That's why you need to know this one. So if U sub doesn't work, you got to go down a different path. And we're going to have some more of those in just a minute. Kind of looks like U sub, but it's a misnomer. It's going the wrong way. Okay? Next problem. Big integral sine of x over 1 plus cosine of x dx. Sine of x over 1 plus cosine of x dx. Okay? Now, do you see anything inside of something else?
No.
No. However, you do see a fraction that has x's top and bottom. And I told you back when we learned U sub that U is usually the what in this instance? The denominator or the numerator? Denominator. U is usually the denominator. So, come out to the side. Du cannot be in the denominator. That's why. Du cannot be in the denominator. It has to be in the numerator. So U is equal to 1 plus cosine of x. What is du? Negative sine of x dx. Do I have that?
Well, you're
Missing a constant, but I've got everything else, right? So, give sign a negative. Here you go. What else do I need to put in there? Negative 1 in front of the integral. I like to put negative 1, that way I don't forget the negative. Especially if you write small. If you write a teeny tiny negative there, you might totally forget about it. Okay? Yes?
So where did the 1 come from in front of the integral?
Because if I'm really multiplying this sign by a negative 1, because it needs a negative, and these two have to cancel each other out. The reciprocal of negative 1 is still negative 1. Okay? All right. I'm going to circle my du this time because I can. Can't really underline it. There's my du. So now we have negative 1 integral du out to the side. What is everything else? Is it just u? It's 1 over u. Do you see that the u is in the denominator, remember? So this is 1 over u. So am I supposed to bring that u up? And make it a negative? No, not this time. What is that? That is ln. Very good. So this is going to be negative ln absolute value of u plus c. I'm going to go ahead and say this now because everybody needs to hear this. Both the absolute value and the plus c are very important. Okay? Is this problem finished? No. So I need to change it back to x's. So in negative ln of 1 plus cosine of x in absolute value plus c. Now I'm finished. Okay. Now we're going to have a few obscure problems. I mean, problems like you've never seen before. But you can do them. Okay, so I'm going to scoot this up. Any questions on this one before I go on to the next one? All right. Next example is the integral of tan x cosine x dx. The integral of tan x cosine x dx. Okay, nothing's inside of anything else. Those are just two functions multiplied together. And usually the case is one is u and the other one's du. Okay? But is either one of those the derivative of the other? No. I can't say u is tangent because the derivative of tangent is what? Secant squared. Now secant and cosine are related, but that's only one cosine. That's not going to work. If u is cosine, what's du? Negative sign. I don't see a sign there anywhere. So, suggestions. Okay, hang on. Let's start with you, Ariel. Change tangent to sine over cosine. What good would that do? Yes, you are exactly right. We're going to use some pre-calc skills here. We're going to change tangent to sine over cosine times cosine. So if If your normal method of doing a problem doesn't work, see if you can do some algebra or some pre-cal to the problem and clean it up and change it. So, as we said, the two cosines are going to cancel, and now my problem is just the integral of sine of x dx. I only have one trig function now. And if you don't happen to know this one, you can look on your flip chart to help you. What is the antiderivative of sine? Negative cosine of x. Very good. Plus c. Don't forget plus c. Okay? So that was kind of weird. Looked like U-sub. It's not U-sub. All right. Questions? Okay. Couple more. The integral of 1 over x squared plus 6x plus 9 dx. Writing a little smaller so I can make it fit on this page. U-sub? Or no U-sub?
No, yes, U-sub.
No, no use them.
Can I just take the antiderivative of each of those terms as it is?
Yeah.
No, I can't. They're in the denominator. Can't do that.
What is happening? Do you separate it or?
No, not when the bottom is all added together. Only when the top is.
You could FOIL it, right? You could FOIL it.
I could factor the bottom, maybe. That might help. We'll come back to that in a minute. Now, does that kind of look like ln-ish a little bit? Little ln-ish there? Because it's 1 over something? So if it's an ln, the bottom would be u, right? If u is the bottom, what is du? 2x plus 6. Do you see a 2x plus 6 anywhere? Nope. So that's not going to work. So, Olu suggested factoring. So I'm going to try that and see what happens. If I factor the bottom, maybe this will turn into something I can work with. How does this factor?
X plus 3 equals
X plus 3 and x plus 3. Oh, that's kind of interesting. Aha. So this is now going to become, I'm going to write a little bigger, 1 over x plus 3 squared dx. Now it's a u-sub. Okay, now think about it. Before you write anything down, we're kind of thinking u-sub. What would u be? X plus 3. What's du? 1. Are we okay with a 1? Yes. We're totally okay with a 1. So u is x plus 3. I'm going to scoot it up. So du is 1 dx, which I already have. So circle the 1 in the dx. There we go. There's my du. Don't have to put anything in there. All right. So now I have a du. What is the rest of it? 1 over u squared. Does everybody see that? Are we all comfortable with that? Don't forget that squared is on the bottom. Okay. ln or no? No ln. Why not? I know I'm harping on this, but people miss this. Why no ln? Because it's got an exponent. So what do? Bring it up. So I'm going to rewrite this as u to the negative 2 du. Not negative 1/2, negative 2. It's just the same number. Do I change it back to x now?
No.
No, I got to take the antiderivative. So that would be parentheses u to the negative 1. And then the reciprocal is still a negative 1. Plus c, and now we change it back to x's. So that's going to be negative 1 over, because it's got a negative exponent, whatever u is. What's u? X plus 3? Plus c. And that one is done. Okay, I've got one more and then we're going to be done. Question?
Why did we put a negative sign outside before the integral, like before we took the inside derivative?
Because, let me go back to the problem where we needed that. The problem we needed that on was this one, okay? Notice the du was negative sine of x dx. What I had in the problem was a positive sign. So I needed a negative. So I had to give it one. This one has u is x plus 3, du is just 1. I had a 1. I didn't need a negative. So I didn't have to put it on there. You see it? Okay. Any other questions? Okay, one more and we're done. You see? There we go. Last problem. Integral of 3x cubed plus 1 over x squared dx. Okay. U-sub?
No.
No. Well, if you have multiple x's in a problem that are multiplied or divided, you have to do a U-sub. But is a U-sub going to work?
Can't you break it?
I'm going to do that in just a second. Right now, by looking at that, if u was the numerator, I might be able to do it. But u can't be the numerator. U has to be the denominator. But if u's the denominator, it doesn't work. So, Destiny, say what you said just a minute ago. We're going to break it into separate fractions. That's the only way we can do this problem. So what we do is 3x cubed over x squared plus 1 over x squared. Now we tried this on a different problem, but it didn't work because the bottom was multiple terms. It only works when the bottom's a single term. So what does the first term clean up to be? Just 3x to the first, right? The exponent subtract, plus, I have to take the antiderivative of that, so I need to bring it up. X to the negative 2 dx. Now we have individual things, don't need a U-sub, everything can be done with its own power rule problem. So now you finish it off, you have 3, and then x to the, what power does x become now? Squared, 1/2 in the front, plus, had a lot of this x to the negative 2 today. Negative 1 in front. Don't forget your plus c. Now in reality, on the AP test, you could stop right there. You don't have to clean it up. I kind of like you to clean it up because that's the way it would look on a multiple choice. So this is 3/2 x squared minus 1 over x. Does everybody see where 1 over x came from? Plus c. And that's the answer.
You put that as the ln 1 over x.
I'm not taking its antiderivative again. It's just 1 over x. So it's ln. Question?
Would you take those points if we left it as minus 1 x to the negative 1?
Nope. I'm just telling you that if you want to match it on the back, you have to change it. Okay? Now, I am officially done with notes, but I want to share something I found on the internet last night that is rather funny. Okay? So I'm actually going to even record this. I'm debating whether or not to leave it on the video, but we're going to do this. Okay. If y equals 1 over x, what is its derivative?
It's 1 over x squared.
Okay,
Yeah.
this is the same thing as x to the negative 1, right?
Yeah.
So its derivative would be negative 1 x to the negative 2, which is the same thing as negative 1 over x squared. Do you agree with me? Okay? Now, watch this. This is pretty funny. D dx parentheses 1 over x equals. Okay? So I'm going to do some very bad math. Let's say I gave this to somebody who wasn't a calculus student and said, tell me what that is. Well, they may go, oh, well, I see 2 x's here. I'm going to combine those two. So I'm going to have a d over a d, and I'm going to have a 1 over an x squared. Okay? Now what's going to happen to the d's? They cancel out. And what do you see between the two d's? A fraction bar, which looks kind of like a what? A negative sign. So it's a negative 1 over x squared, which happens to be the derivative.
Oh.
That's pretty cool. Now, that only works on that problem. It only works on that problem. But it's calculus. I did calculus, yay. All right.